Today we are going to look at additional strategies to solve quadratic equations. So in the previous lesson, we did the square root method and completing the square. Today, our first method we're going to look at is factoring. So here are your steps. Step 1, write the equation in general form. Remember, general form is ax squared plus bx plus c equals 0. Step 2, factor the polynomial. Then you're going to use the zero factor property to set each factor equal to 0. So what I mean by that is you end up with one thing times another. So often, let me change that. I don't want you to get mixed up with the letters. So if I have p times q equals 0, then you set the p, which is your first factor, equal to 0, or the q factor equal to 0. And then you just solve the resulting equation. If that's clear as mud, let me make it crystal clear. So in this example, it says solve x squared plus 5x equals 24. So let me run through your steps. Step 1, write the equation in general form. So how do you do that? You would subtract 24 from both sides. So now you should see that is general form. Factor. Okay, well, the number in front of x squared is 1, so we like that because that's the easiest method. You make it x times x is x squared. Then what two numbers multiply to negative 24, but add up to 5? And that is 8 times negative 3. So then x plus 8 times x minus 3. So this is what I meant by the p times the q. So x plus 8 is the p, x minus 3 is the q. It's a placeholder for something times something. So I have x plus 8 times x minus 3. So then this is the zero factor property. You said x plus 8 equal to 0 or x minus 3 equal to 0, and then solve those. All right, let's see. Let's actually do some. So in example 1, letter A, I have 2x squared minus 11x plus 5 equals 0. So it is in general form, so check. We got that. Then I'm going to factor this. So I have been emphasizing that we need to do trial and error. Okay, trial and error. Well, I'm looking for two factors that multiply to 2x squared. So that's going to be 2x and x. Now, do you see it ends in a plus 5, but the middle term is a minus. So I can reason out that this has to be a minus and a minus. Then you have two choices. This is either 1 and 5 or 5 and 1. So what I'm going to do is I'm going to just do the outer inners with both of those. And if I put this one in, that's 2x times negative 5 is negative 10x. The inners minus 1x. I got it. I got it on my first try. So that factored. So then I use the zero factor property that says set 2x minus 1 equals 0 and x minus 5 equals 0. I could add 1 to both sides and divide by 2. Add 5 to both sides, I get x is 5. Since you're just watching the video, if I'm going too quickly, just pause the video. Pull it back, rewind it a little bit, do whatever you need. Okay, in this one, in letter B, 4x squared plus 4x plus 1 equals 0. If you really know your Algebra 1 factoring, this is a perfect square trinomial. So I end up with 2x plus 1 times 2x plus 1. Well, when you have a factor that repeats, I'm not going to write 2x plus 1 equals 0 twice, okay? That would be silly. So I get one answer, but there's two of them. In a little bit, I'm going to explain what that means. All right, now in letter C. Okay, so this is going to be a really cool problem. X squared plus 9 equals 0. I know this can't factor, okay? I'm going to do this off to the side, and you don't really need to write this down. But if I did x plus 3 times x plus 3, that's x squared plus 6x plus 9. That doesn't work. If I do x minus 3 times x minus 3, that doesn't work. And the problem is that my outer and the inner are not canceling. The outer and the inner are not canceling. So watch this, okay? This might blow your minds, but then you're going to use this technique. And what we said before is if I had the sum of two perfect squares, x squared plus 9, I can't factor it over the real numbers. And you may not have picked up on that earlier this year when I said you could not factor over the real numbers. So watch what's going to happen. This is x plus 3i times x minus 3i. Okay, just write it down for now, and then I'll work it out in a moment for you. So this gives me x plus 3i equals 0, x minus 3i equals 0. So I'm getting those two answers. So what I meant is, what if I multiplied that out up here, okay? Let me draw. What if I take this and I multiply it out for you? That's x squared minus 3xi plus 3xi minus 9i squared. Do you see now that the minus 3xi and the plus 3xi cancel? And what's I squared? I squared's -1. Oh, so here's something really cool. Now I can, in fact, factor over the complex numbers, x squared plus y squared, if there's two perfect squares. All right. Now, okay, so that's factoring. So if you know how to factor, this is going to be simple. If you don't know how to factor or you struggle with factoring, we're going to have to fill in those gaps, okay? And so you can get into Math Lab. You can ask me for gold period office hours. I can meet you before school. There's lots and lots of ways to get some help with that. So be encouraged that we can get it worked out. All right, so factoring is another method. So we had square root method, completing the square method, factoring. Well, we did quadratic formula. That's a fourth method. So if x equals negative b plus or minus square root b squared minus 4ac all over 2a, the value under the square root, that's the b squared minus 4ac, has a special name, and it's called the discriminant. You did do this in Algebra 1, so we might have to get the cobwebs out here. But there are three cases. If b squared minus 4ac is positive, greater than 0 means positive, then there are two distinct real roots. If b squared minus 4ac is exactly 0, then the function has one repeated root. And I just realized that maybe I need to clear something up. A root is also another word for 0, which is another word for solution. Root means 0 or solution. On a graph, the root or 0 is the x-intercept when it's real, okay? On a graph, the root or 0 is the x-intercept when it's a real root, okay? because we'll talk about that now in this third row. So when b squared minus 4ac is less than 0, that means is negative. There are two non-real roots. Non-real means complex. So you can use that interchangeably, non-real or complex. So this may not have made any sense, okay? And so we're going to make a connection now to the graphs. If I have f of x, so I want to make sure you're with me here. If I have a quadratic function in general form, ax squared plus bx plus c, if the a value is positive, that means the parabola is opening up. There's three cases, and these are the three cases. When the discriminant's positive, that means there's two distinct real roots. That means the parabola is going to cross the x-axis twice and have two x-intercepts. Here's what's cool, and I'd like to go back up to part B up here. Do you remember when I said, hey, this is kind of interesting that you have two repeated roots? What that means graphically is the graph is bouncing off or touching just one time. And then in our third case, when the discriminant is negative and it opens up, it means there's no real roots. There's no x-intercepts. Okay? It does have two solutions, but they're complex. Okay? All right, then let's look when a is negative. Okay, from the general form. When a is negative, that means the parabola opens down. And I'm going to go through the three cases again. So if the discriminant's positive and the parabola opens down, it's still going to have two real roots. It's going to cross the x-axis twice. When the discriminant equals 0, there's one repeated root, real root, and it just is like bouncing right at that point. And then in the third case, where the discriminant b squared minus 4ac is negative, it's not going to touch the x-axis. There's going to be no real root. Or, in other words, when we say no real root, they're complex. No real roots or two complex roots. All right, so in example 2, it says calculate the discriminant for each. So the first thing I want you to do is underline discriminant, and discriminant is b squared minus 4ac. Determine the number and type of solutions. So I'm asked to do three things. Calculate the discriminant and determine the number and type of solutions. So I'm going to write it down every time so that we've written it 4 times at least. So b squared minus 4ac. A is 4, B is 8, C is 3. So that is 8 squared minus 4 times 3. That's 64 minus 48, which is 16. So that's the discriminant. The discriminant is positive. So there's two distinct real roots. And I'm looking right above, right here. Okay, this is the case. This one opens up, so it's actually this picture. That if you got your graphing calculators out and sketched it, that's what it would look like. All right, I'm going to pause a moment. I want you to try letter B and really pause the video. All right, I'm going to trust you paused. So A is 1, B is -8, and C is 16. So I'm going to write it out again because that's going to help me memorize it. -8 squared. Make sure you have a parenthesis around that. This is 64 minus 64, which is 0. And so if you look above, that is 1 repeated real root. And it's a bounce off, okay? So I have my discriminant is here, and then there's 1, and it's a real number, but it's repeated. All right, try letter C, pause the video. All right, so A is -3, B is 2, C is -4. So I hope you wrote the formula again for the discriminant, b squared minus 4ac. So that's 2 squared minus 4 times -3 times -4. So my discriminant is -44. Now you can write it as, I personally would prefer you to write that this is 2 complex roots. It is 2 complex roots instead of saying no real roots, because there are 2 roots, but they're complex. All right, example 3. It says find the value of t for which 2x squared minus 3x plus t has exactly 1 solution. All right. So Algebra 2 has been about thinking and analyzing. And you've heard me say multiple times, let's play the what do I know game. So let's look back up at the 3 pictures. And what do you know if a quadratic function has exactly 1 solution? Well, in order for there to be 1 repeated, or just 1 solution, the discriminant is 0. Okay, so I'm going to write that down. I'm going to write down that b squared minus 4ac has to be 0. Okay, that's what I know. So when you see a problem on the homework and you think, she didn't do one exactly like this, I want you to know that I've given you all the tools in your tool belts to figure it out. So I don't want you to panic. I don't want you to give up. I want you to look through the notes and think, what do I know? Because Mrs. McInerney is not going to give me a problem I don't know how to do, okay? So my B is -3, the A is 2, and my C is T, okay? So that's a little weird. So I get 9 minus 8T equals 0. I'm going to add 8t to both sides to make it positive, and then divide by 8. So t is 9/8. So do you see, like, we just took one step, and then we figured it out. So super cool, super cool. All right, example 4. I would like you to pause the video and try this. Go the whole way. All right, hopefully you paused it. So remember, step 1 in doing quadratic formula is make sure it's in general form. And remember, a few of you got caught on the skills check because you forgot to do that. So thankfully, this one is in general form. So A is 6, B is -2, C is 3. So write down quadratic formula every time. It helps so that you're not making a little mistake. So I put -2 plus or minus square root. Remember, we talked about b squared is always going to be positive, or at least I should say non-negative. So I'm getting x equals 2 plus or minus square root 4 minus 72 over 12. And I really, really, really do hope you paused the video. If you're just sitting and copying, then you're robbing yourself of the opportunity to show your learning, to show the growth through the process. So if you didn't pause it initially, please pause now and really try to finish it. Okay, so here we go. I get 2 plus or minus square root -68 over 12. When I see a negative under a square root, I pull out the I. Remember, when you have an I in your answer, okay, remember, answers must be A plus BI form. So I'm going to go ahead and split right here, and I'm going to multitask. I know that 68 can be written as square root 4 times square root 17. So that's 1/12, or not 1/12, sorry, 1/6, plus or minus 2 square root 17 over 12i. All right, this one was a tough one. So there we have it. And notice, okay, pause a minute and like really think about this, because this is really cool how we can connect everything. Do you see the discriminant? The discriminant is what's underneath the square root, and I'm highlighting it here in case you didn't notice that. So the discriminant was negative, and I got 2 complex answers. So that's super, super cool. All right, so here's a reflection question, and I would like you to pause, write out what you think. When does solving by factoring work? Only when the expression factors. When does using quadratic formula work? All the time. Even if it factored, you could do quadratic formula. All right, that finishes the notes.